Thank you. Today we're looking at Glencoe Accelerated Math, Lesson 8.1 on solving equations with rational coefficients. So, solving an equation with a rational coefficient works exactly the same as solving an equation with whole number coefficients. Today we're looking at more of one-step equations as opposed to two-step or multi-step. So the process is fairly simple. We're going to simply do the opposite of the operation that we're given. Okay? So if we look at example 1 on the wrong page, sorry about that. If we look at example 1 on page 325, we have 4.2x being equal to negative 52 and a half. Okay? So, if I have a 4.2 in front of my variable x, what operation is there that's not written? Multiplication, thank you. So what's the opposite of multiplication? Division. So to get the variable x by itself, which is the goal when solving an equation, we're going to divide both sides by 4.2. And when we do that, we find that x is equal to negative 12.5. Something that I want us to pay close attention to. You have to show your work. You have to show that what we do to one side of our equation, we do to the other side. We can't do something to one side of an equal sign, not do it to the other, and call the two quantities still equal. That doesn't work. Yes, sir. I need a pass. Walk behind the camera, please. All right. So, what we're doing when we write our equations, we need what we start with, what we did, what we end with. And when we have more steps, we'll use the what we end with and what we start with as the same line. So then we would repeat the what we did, what we end with, what we did, what we end with, as many times as we need. So if I tell you that today we have one-step equations, how many total lines on our paper is this going to take up? 3. What we start with, what we did, what we end with. Okay? Alright. We like decimals because decimals are easier to work with.
This was left.
Okay, just hold on to it for me, please. I'll get it in just a second. What we don't like as much are fractions. And especially when we get to our functions, we're going to have more fractions. Okay? So let's look at an example that does involve a fraction. Like the one in example 3. I like example 3a for 2 reasons. I like example 3a because it gives me the opportunity to show you that we can rewrite that example in a different form that we may see problems written in. And I like example 3b because we're not able to. So if we look at example 3a, I have 1/4. What's my variable? In example 3a. What?
Y.
Y. That's equal to negative 8, I think. Correct? Yes? Okay. Love it when my memory works. Okay. First of all, we have to make sure that this fraction bar does not extend over our variable. If the fraction bar extends over our variable, then that takes our variable y and that puts it in our denominator. That will give us the inverse of our answer. We don't want that. We don't want the reciprocal of our answer. We want the actual answer. Okay?
When you multiply both sides by 1/4.
We would not multiply both sides by 1/4. Now, 1/4 is called a unit fraction. And unit fractions always have a numerator of 1. So sometimes instead of saying 1/4 y equals negative 8, you'll see it written as y over 4 equals negative 8. Yes, ma'am. I need a pass. So how would we eliminate that 4?
Multiply by 4.
Right, we would multiply by 4. Then my 4's would cancel, and I'll be left with y equals negative 32. However, if we left this as 1/4 y, would we multiply by 1/4 still?
Yeah.
No, what would we do? We'd multiply by the inverse. Isn't the multiplicative inverse of 1/4 4? So isn't that what we did? So that's how that part works. Do we have any questions about the first two examples? Have we seen things like this before?
No.
Some no, some yes?
Yes.
Okay. When we start working, if you're a no person, make sure I stop and talk to you today as we're working, okay? Everybody got it? All right. Let's look at one more. If I look at example 3b, what does example 3b say? I'm sorry? Negative 3/5 x is equal to what?
Negative 6 over 25.
Okay, that equals negative 6 over 25. So, in this situation, can I just put x in my numerator and multiply by 5? No. I don't have a unit fraction. So what would I do?
Find it.
There's actually two different ways that we can show our work for this. Option 1 says we use the fact that division is the opposite of multiplication, and we show that we divide both sides by negative 3/5. I could do that. When I divide by a fraction, what actually happens? By the right, you multiply it by the multiplicative inverse or the reciprocal, right? Could we write it that way too? Could you write this as multiplying by negative 5/3 instead of dividing by negative 3/5? Does it matter which one you use? No. It doesn't matter. Personally, I'm going to show that I'm dividing by 3/5 because that way in my mind, I'm showing that I'm using the opposite operation that I'm given. Okay? So I'm going to show that I'm going to divide both sides by negative 3/5. leaves us with x equals some fraction that I need to work with. We are lucky enough to have calculators that have fraction buttons. I'm going to do it longhand because calculators will not always have fraction buttons. Negative 6 over 25 divided by negative 3/5 is equal to negative 6 over 25 times negative 5/3 because we have to KCM. Negative 6 times negative 5 is a positive 30. 25 times 3 is 75. Dividing both by 15, I get 2/5. So therefore x equals 2/5. My calculator people, was I correct?
Yes.
Good.
Wait,
Doing-
can you do that in your head?
I'm sorry, I'm hearing a little bit of background conversation. Can't I do that in my head? In what way?
Find x, the answer, negative 6 over 25, and then 2 over 5 times negative 3 over 5 equals 6 over 25.
Okay, so that's how we would check it. I don't want us solving the equations in our head.
That's why we're doing all that.
The reason why we don't do it in our head is because this is the first lesson in the chapter. So what would that tell us about the equations coming forth?
Probably a little bit harder.
Right, they're going to get harder and they're going to involve more steps. One-step equations, yeah, you could probably do those in your head, but I want you to show your work anyway. We're going to be getting to the point where we have multiple steps. Okay? It has to be done on paper.
Okay.
All right? Yes, sir. I need a pass. Okay. Any other questions? Okay. Thank you very much.